Hello, my name is Adrienne Wallace, and today I will discuss pedagogical differences between media and applying the sections framework. I will also analyze several technologies used in my classroom, highlighting their pedagogical differences through learning theory, affordances, and instructional benefits. Let's begin with the purpose of pedagogical differences of media. Tony Bates explains how different media, text, audio, video, computer, social media, virtual reality, augmented reality, and AI carry different pedagogical strengths. These differences shape what and how teachers should teach. It is not about finding a perfect medium, but understanding each medium's unique characteristics and matching them to learning outcome. Before choosing any technology, instructors must reflect on 5 essential questions. Start with key teaching questions. What is my foundational perspective on how people learn? What learning outcomes do I want? What teaching methods fit those outcomes? What are the unique educational affordances of each medium? What resources do I have? Bates explains that the type of media affect learning based on 3 elements. Content, different media represent information differently. Text is strong for abstract concept. Video is strong for concrete images, motion, and real-world examples. Simulations show relationship between variables. Content structure. Some media are linear, text, lectures, audio. Others show complex interacting systems like video, simulation, and virtual reality. Skills. Media influence how well students develop. Cognitive skills, analyzing, problem solving. Psychomotor skills, hands-on tasks. Affective skills, empathy, and emotions. Pedagogical affordances or unique characteristics. Bates describes affordances as what a medium makes easy or possible for learners. Example, video helps show processes in real-world demonstration. Text encourages interpretation and deeper reflection. VR provides immersive skill development unavailable in text or video. Social media provides collaboration, networking, and peer feedback. As teachers, we must match these affordances intentionally to learning goals. What are the practical takeaways for teachers? Teachers are encouraged to reconsider which content should be taught through text versus video versus audio. Identify content where a different medium would improve student understanding. Look for new learning outcomes that become possible when new media are used. No medium is universally best. Media should be chosen because they help achieve specific learning outcomes, not because they are trendy or convenient. In 1991, William Graver's article introduced and explains the concept of affordances. So let's take a look at what are affordances. Affordances are action possibilities that emerge from the relationship between a person and an object. Affordances depend on both physical properties of the object and the capabilities of the user. They can be perceptible affordances, where the user can see and feel the action as possible. For example, the blue underline links on the Wikipedia pages. They look clickable because there's a color and there's an underline, and where you hover over them, the cursor changes, clearly signaling you can click them. Then there's hidden affordances. The action is possible but not visible. For example, on Instagram, you can swipe left on a post to see more images in a carousel. If you don't know this gesture, nothing clearly tells you that the swiping will reveal more content. Then there's false affordances. The design suggests an action that is not possible. Example, a button graphic on a website that looks clickable, raised, shadowed, styled like a real button, but does nothing when you click it. Correct rejection, there's no affordances and no cue suggesting one. Example, a static image in a PDF document with no hover effects, no cursor changes, or visual cues suggesting it's clickable. Perception and action are linked. Gaver emphasizes that when affordances are perceptible, people do not need conscious reasoning or memory. They just simply see what to do. Good design equal making affordances visible and intuitive. Culture and experience shape interpretation. Affordances exist whether perceived or not, but culture and experience influence one, which affordances people notice, and two, how quickly they learn to use them. However, Gaver argues that factors should not define the affordance itself. Designers should focus on the physical and perceptual cues. Sequential and nested affordances. Gaver extends the concept of affordances to complex actions. Sequential affordances. One affordance reveals another over time. Example, using an ATM. Insert the card, enter the PIN, select transaction, withdraw cash. Each step unlocks the next. Nested affordances. Multiple affordances are organized in space, where one becomes meaningful only in relation to a larger object. For example, on Facebook, a post is an affordance. You can interact with it. Inside the post are nested affordances. There's the like, comment, share, click profile name, click hashtags. The larger larger object is the post, contains multiple smaller affordances within it. These explain how users discover system behavior through interaction rather than instruction. Affordances across modalities. Affordances aren't only visual, they can be tactile, affordances that are communicated through touch or physical texture, guiding the user by how something feels. For example, the textured home button on an older iPhone model. The slight indentation and circular ridge made it easy to locate by touch without looking. Your finger could feel where to press. Auditory. Affordances communicated through sound, where audio cues signal what action is possible or what just happened. For example, in many cars, a repeated chime sounds when the seatbelt isn't fastened. The sound signals that an action is required, buckling the seatbelt. Gaver suggests using multiple sensory modes to communicate what users can do. Implications for interface design. Gaver argues affordances help designers create transparent, easy to learn systems, align technology features with human perception and action, reduce the need for instructions, avoid false or misleading cues. He stresses that the goal is to focus not on the user alone or the technology alone, but on the interaction between the two. The overall takeaway, Gaver positions affordances as a foundational design concept. Good design makes action obvious. Poor designs hides or misleads. He encourages designers to analyze what action technologies truly support, whether those actions are visible, how sequential, nested, visual, tactile, and auditory cues guide learning. In 2019, Tony Bates introduced the sections model as a practical framework to help educators choose the most appropriate media and technologies for teaching and learning. The model emphasizes aligning media choices with pedagogy, context, learners, and instructional goals, not simply picking tools because they are new or popular. The acronym SECTION stands for key factors teachers must consider. S is for students. Educators must examine students' needs, backgrounds, digital skills, access to device and internet, learning preferences, and potential barriers. The goal is to choose technologies that support inclusion, accessibility, and equity. E is for ease of use. Technology should be easy for both teachers and students to use, set up, navigate, troubleshoot, and maintain. Complex technologies can create frustration, reduce engagement, and waste instructional time. C is for cost. This includes upfront costs, licenses, subscriptions, long-term sustainability, maintenance, required devices, training time, and hidden costs. Bates encourages educators to weigh costs against educational benefits. T is for teaching and learning. This category focuses on the pedagogical fit of the media. Teachers should ask, does this tool support active learning? Does it help achieve learning outcomes? Does it align with my teaching philosophy? Different media support different approaches. Interactive video for engagement, simulations for skill practice. I is for interaction. How well does this technology support different types of interaction? Student interaction with the content, student interacting with another student, and student interacting with the teacher. High quality learning usually requires meaningful interaction, so technology should promote dialogue, collaboration, feedback, and active participation. O is for organizational issues. Schools and districts must be able to support the tool. Considerations include IT support, training availability, tech policies, compatibility with existing systems, administrative approval. If the infrastructure is weak, implementation may fail. N is for networking. This refers to how well the media connects learners to broader networks, peer networks, professional networks, global communities. It also addresses how collaborative and shareable the technology is. S is for security and privacy. Educators must ensure student data is protected. Tools must comply with privacy laws, avoid unnecessary data sharing, and maintain safe learning environments. Overall purpose of the sections model? The sections model provides a systematic, evidence-based method for choosing technologies that improve learning rather than distract from it. Bates emphasizes that the best technology is the one that meets student needs, fits the teaching goals, is accessible and affordable, supports interaction, is easy to use, can be supported institutionally, and protects student privacy. Ultimately, the model encourages educators to be intentional, reflective, and strategic in integrating media into instruction. Here are some examples of how and why I apply Sections Framework for media and technology selection in my web development class. First, we use Google Classroom as our district's learning management system. S, for students, the students at Terra High have varying levels of digital literacy. Many are beginners and need a platform that has a familiar interface across tools. Once students learn one Google tool, they can navigate others easily. Google tools give immediate visual feedback, which reduces the frustration of setup, software installation, or troubleshooting, and are accessible on all Chromebooks used in the classroom. This lowers cognitive load so that they can focus on content and not the platform. E, ease of use. Students need a tool they can open and start working on within seconds. Using Google Workspace for education, classroom, docs, drives, sites, and videos creates ease of use because everything functions inside one connected ecosystem rather than scattered platforms. Because all tools live under one system, they are designed to work seamlessly together. Real-time monitoring and feedback. Teachers can view student work live and leave comments instantly. Google Classroom is extremely easy for students to learn within minutes, which removes barriers and increases time spent on actual assignments. C is for cost. All of these platforms are free and fully functional for instructional needs. Students do not need to pay for any of them. They are cost-effective and sustainable for my classroom and our district. T is for teaching and learning. You need a platform that supports performance-based tasks that fully aligns with your instructional goals and enhances hands-on, authentic learning. Google Sites plus CodePen plus Nearpod plus Google Vids promote constructivist learning. By using these platforms, students can build their own digital artifacts. They are not just completing assignments, they are creating projects that mirror real-world technical scenarios. I is for interactivity. Nearpod and Google Vids align with Meyer's cognitive theory of multimedia learning by combining visual, auditory, and interactive elements to engage multiple processing channels while preventing cognitive overload. Embedded questions and quizzes inside the videos support behaviorism and formative assessment by providing immediate feedback and capturing real-time understanding. Nearpod videos function as both engaging bell ringers and adaptable scaffolds for developing HTML and CSS proficiency, while Google Viz can quickly generate AI-assisted lesson summaries or self-paced remediation and enrichment videos to support absent students and flipped classroom models. High interactivity equals deeper engagement and more active learning. O is for organizational issues. Within East Baton Rouge Parish School System, Google Classroom enhances instruction by providing organizational clarity, facilitating formative assessment and feedback, promoting collaboration and communication, enabling authentic, process-based learning, allowing teachers to design coherent, structured digital learning environment. These tools create minimal organizational barriers and no technical dependency. N is for networking. Cloud-based infrastructure, no local server required. Files are stored in Google Drive. Google's enterprise-level infrastructure has a distributed cloud that handles scaling without district maintenance. S is for security and privacy. Google Sites, CodePen, Nearpod, and Google Vids are safe for students K through 12 when configured properly. Student data is protected under FERPA guidelines. Admin-level district controls IT oversight. Only students with class codes or district emails can join. Assignments are automatically tied to student accounts. Communication stays inside the platform, limiting external phishing or unsafe attachments. Why these tools together? Using sections reveals that Google Sites, CodePen, Google Vids collectively support creativity, accessibility, autonomy, and authentic demonstration of skills. These apps enhance my instructional strategies by allowing students to build interactive websites, create e-portfolios, and engage with clear video instructions, resulting in a powerful, future-forward, real-world experiences. In conclusion, these differences highlight the importance of selecting tools intentionally, choosing technologies whose affordances amplify specific instructional goals and align with evidence-based learning theory. Different tools support different kinds of learning: procedural skills, coding and simulations, conceptual understanding, animations and videos, social learning, collaboration tools, and reflection portfolios. Choosing a technology is choosing a way of learning. Pedagogical affordances help us select better tools, design better learning experiences, and support deeper student engagement and understanding. Effective educators match tools to the learning goals, not the other way around. Thank you.